listen, I'll just teach. Because it'll make me feel better. This helps with, what number is this on your worksheet?
On our worksheet, this is number 9.
Yeah, so this one, number 9, I think is a little harder than this one. But this is an example of one that you can't just use the shortcut on, because one part is out of the square root and one part is in the square root, so you can't say like what's the degree of the numerator, what's the degree of the denominator. But you can go through and divide everything by that denominator, which happens to be the square root of x squared. Do you agree that's our degree term down there? Yeah? No! You cannot separate addition under square root. You cannot separate addition under square root. The square root of 4 squared plus 4 squared does not equal 4 plus 4. So, if I was going to go through and divide in the bottom, it's all under a square root, so I could say I'm going to divide by x squared over x squared plus 4 over x squared, because I put it all under the square root, so I haven't broken any walls here.
How do you know when to divide by, like, the x squared and everything? Like, that's what I'm confused on.
You can do that every single time. Like, every single time that you see a problem, if you want to, when you're finding a limit going to infinity or negative infinity, you can, the rule is you can divide by the highest degree of the denominator and go through and simplify, and it'll always give you the asymptote. We don't do it for just basic rational functions very often because we just remember the rule. Like, we remember if the degrees are the same, oh, I just take the leading coefficient, so why would I go through and do all that work? But you could. It works every single time. So that's kind of the thing here. On the top, and what's on your worksheet, I think it's the opposite way on your worksheet, like there's a square root in the top and not a square root in the bottom. If I take x divided by the square root of x squared, I have a problem because one's in a square root and one's not in a square root. But what's so nice about this? What's the square root of x squared? Those are the same. So on the top, since that's not in a square root, could I write that as x over x plus 3 over x? Because I'm still dividing by the square root of x squared, but it actually just equals x. It does. So I get 1 plus 3 over x over the square root of 1 plus 4 over x squared. And remember, the reason we do this is because we know the limit of any constant over any power of x going to infinity is always going to go to 0. So I know that this is going to go to 0, and this is going to go to 0. And this one works out so nice, it's just 1. Right, you don't have to do conjugates. The conjugate's like when there's a square root and then plus or minus a number outside of the square root. What's the one on your worksheet? What number is that? Give me that problem.
Alright, the limit as x approaches infinity, 2 times the square root of x plus x to the negative first power divided by 4x plus negative.
I really hate that I wrote plus negative 2 there. Why would I just write minus 2? An Asian moment? I don't know. So I'm still so confused by why that's funny. Like, I don't get it. I know, and I don't know why you know that's racist. I don't understand how no one else finds it inappropriate but me. I find it inappropriate and it makes me uncomfortable. Okay, same idea on this one. I'm not going to work this all the way out for you, but if you're going to go through and divide by the highest degree in the denominator, you're going to divide by x. So on the bottom, it's really great. You can divide by x, you can divide by x. I should probably rewrite this. On the top, you could write 2 square root of x over x, but you can't really simplify that very well. So you want to think about, just like over here, we took something in a square root and took it out. I'm going to divide by x, but I want to put it under a square root. So the square root of what would be equal to x? theory, those are equal to each other. And so I could say, instead of just taking the square root of x divided by x, I could take 2, well, why write that 2 so big? 2 square root of x and divide that by x squared, because the square root of x squared is equal to x. I'm going to make one big square root sign there. Well, it just, the 2's not under the radical, so there's no need to, like, let's deal with that in a minute. I'm not doing something extra special here, probably not this hard on your quiz, but this is also x to the negative 1. You can deal with that a couple ways. One, that's not under a square root, so we could just divide by x to the negative 1 over x. And do you know how to simplify that?
Just be 1 over x squared.
Yeah, it just would be 1 over x squared. The other way to deal with that is to know that that's just 1 over x. And then when you divide by x again, it's just 1 over x squared.
Wait, so it's 1 over square root of x or 1 over x squared?
1 over x squared. So I kind of have a big mess up here, but I think I'm left with, I have a 2 out here. And what would x over x squared give me? 1 over x, so it's technically still under a square root there. Plus 1 over x squared all over 4 minus 2 over x. And now you could do the limit as x is going to infinity. Whether it's under a square root or not, you can still make those things go to 0. So this is going to 0, this is going to 0, this is going to 0. Is my answer 2 over 4?
Yeah. What? 1 over 4.
What?
0 over 4.
This is 0, right? This is multiplication, so if this goes to 0 and I multiply by 2, that's going to be 0, right? It was a trick,
God.
which is just 0. So I wanted to show you this one. I don't know, I just didn't think I had another example this morning. Because I wanted to show you that this is where knowing to divide through by the highest degree, this is where it comes in handy, because you can't just take the rule sometimes when one part's in a square root and one part's out of a square root. So there you go. Share that with your friends.
So the answer is 0?
The answer is 0.